Okay, the last conic section that we get to talk about is called hyperbola, plural, of course, hyperbolas, and it is section 9-5 in our textbook. So again, I'm going to start off with this verbal definition, and then I'm going to go to the picture to get the geometric. I mean, it's verbal because I'm giving you the words, but it's basically the geometric definition of a hyperbola. And you'll see how they're all somewhat connected. Okay, similar to an ellipse, a hyperbola is the set of all points in a plane such that the absolute value of the differences of the distances from the foci again is a constant. Okay, now how do you write that sentence mathematically? I'm finding the difference. Remember, we have two foci, so PF1 minus PF2, but I want the absolute value of that, because it doesn't matter which one I start with, is always a constant. And what is that constant? Yeah, you guessed it, it's 2a. Okay, so let's go look at the interactive one that we have, because we've talked about it. So we have one that looks like this. All right, here they're choosing points A and B instead of calling it F sub 1, F sub 2. Okay, but the difference between the distances, so any point on here, okay, if I go from P to A and P to B and I subtract these two things, I'm always going to get the same number. So you can see that the difference is staying the same, but what's changing is, you know, exactly where the point. So this is the set of all points that we have on here. Wonder if, okay, so if I got Q, same thing is happening with it, okay? But P, it could be on either branch. That's doing PA minus PB. And now, one thing that I want to point out to you that you're going to find out, we're going to talk about, is that this hyperbola opens this way. So this particular website calls it east-west. I still call it horizontal because the branches are going horizontal. You could also have it looking like this, okay, which is what we refer to as a vertical, or they're calling a north-south. Same kind of thing. Any points on these curves, when I take that point and find the distance to the two different foci and subtract, I'm always going to get the same number. So let's go talk about what you need to know about it, and we're going to label it in our picture so we can know. So first off, these 2 points, the points that are on, do I get to name that? These right here, let me go to a different, you can see better. Okay, so this right here, the actual graph of the parabola, are called the branches of your parabola. Okay, so those are your branches. The point on the branch, those are your vertices. Okay, and now, of course, they're going to make it a little bit, I mean, you know, it's not really that hard, but they just have to. The points, the part of the hyperbola is not really part, but it's basically what assists us in graphing. The distance between the two vertices, that is referred to as your transverse, verse has vertices, axis. And that means the one that doesn't have the vertices, they're labeling it C1 and C2. This is called your conjugate axis. I don't know why that's happening. Conjugate. So you could think of it like the other one that we had that's major and minor, but the difference is the transverse axis doesn't have to be longer than the conjugate axis. But just like we had with our ellipse, the transverse axis has a length of 2a and the conjugate axis has a length of 2b. So that is how they are similar. Okay, this is my horizontal hyperbola, and this is my vertical. This is pointing again to the vertices. Okay, why? Golly, this is what I need. I don't need this. Lovely. All right, I'm going to pause a second and try to get this figured out. So I'm not sure that I got it figured out, but hopefully it won't keep happening. We'll see what happens. Okay, so we've got it all labeled. We've got our center, we've got our transverse axis, our conjugate axis, our vertices. They're called the endpoints of the conjugate axis. But again, we have two really important things that it's not going to let me write. Let's try. There we go. Two really important things that we got to remember. We still have that relationship of c squared, a squared, and b squared, but this time it's going to be plus. And what you got to remember is a squared is always, what I refer to as always positive, and you'll understand as I do some problems and show you the equation. But it's something I hope you'll go back and look at when you're trying to do things to help yourself remember what we got going on. Okay, so let's go fill in what does our standard form look like. And very similar to the ellipse, we've got x minus h squared. There it goes again. This time it's the difference. So it's y minus k squared. That's a minus. Okay. Now remember I said a is always positive. So if it's something minus something else, then a squared is always going to be here. Which means, and I don't like that, so I'm going to erase it and see if it won't happen again. Okay, and so the key, as we pointed out up here, okay, one of them is horizontal. This one right here is considered horizontal because the branches are intersecting your x-axis, and this one is referred to as vertical because the branches are intersecting the y-axis. Okay, all right. And of course that can change, but the point is the parabola opens up and down. So what is the difference in the equation is that it's y minus k quantity squared minus, that's not an x minus h quantity squared. And again, my a squared has to be under my positive term. So it's not that it's going to be bigger. It won't always be bigger, but it's definitely going to be underneath whichever term is positive. And the reason I say positive is because it doesn't always have to be first, but in standard form, it is first. Okay. Now, you notice there were some dotted lines in your parabolas. We're going to talk about how to get those dotted lines, and they are important because they kind of tell us how to graph it, and they are called asymptotes because as you graph the parabola, you should be approaching the asymptotes. Okay, now they're easy to get to. I'm going to go ahead and write the form down here, but I'm going to tell you easily how to get them when we're doing it. Okay, this one is y minus k equals plus or minus m times x minus h. Oh, poo, it's not m, y'all. M is the slope. So what is the slope? Slope is y over x. What's underneath the y is b. So this is going to be plus or minus b over a. And then over here, this is going to be y minus k equals plus or minus something x minus h. Again, it's the slope, and the slope is y over x, so that's a over b. So you might have a hard time remembering if it's b over a and a over b, and hopefully when we graph some, I can make that easier for you. If you don't get it from the video, please email me or come see me to ask me. All right, so that's the information. Let's go do some problems. If my program will cooperate, trying to get it to turn the page, probably going to turn it twice. There we go. All right, example 1. So write an equation for a hyperbola with vertices at 6, 0. So 1, 2, 3, 4, 5, 6, 0. 1, 2, 3, 4, 5, 6, negative 6, 0. So hopefully you got from that the center is halfway between those points, and that's your origin. And if these are my vertices, then I know the hyperbola has to open left and right, which means my x squared is going to be my positive term. Okay, so I'm going to put it first. X squared minus x. All right, so there's nothing added to it because I'm centered at the 0, 0. Okay, it opens horizontally because my vertices are changing on the horizontal. How far did I go? So that's a center, that's a vertex, that's a vertex. How far is it from the center of the vertex? Just like we did for the hyperbola? Just like we did for the ellipse. How far away is that? That's 6 units. So I know that A is 6. There's that green thing showing up there. And that means underneath. Oh, please don't. Oh, good. Okay. So let's hopefully that won't continue. So 6, which means underneath the x, I'm going to put 6 squared, which is 36. The foci are at 8, 0 and at negative 8, 0. Okay. Now, this is another thing to remember, and I didn't point it out at the beginning, but I told you back in the parabola, the foci are always inside the curve. So that lets you know that it has to be going that way. But just like with our ellipse, the distance from the focus to the center is c. So I know that c is 8. Okay? So I'm going to come down here and say c squared equals a, don't do that. C squared equals, y'all, c squared equals a squared plus b squared. Now, if you have any trouble remembering this, y'all, because that's very similar to the ellipse equation, if your standard form equation is a minus, this is a plus. In the ellipse, this is a plus, and this will be a minus. Okay? So, c squared is 8. So that's, c is 8. So c squared is 64. A squared is 36. Plus b squared. So b squared equals 64 minus 36, which is 28. So if all I had to do is write the equation, I'm done. Now, I don't have to graph it, but just to give you lots of examples in graphing, I'm going to go ahead and graph it. So I have C, I have my center, I have my vertex. I need to know how far to go up and down. So how far am I going to go up and down? The square root of that number. Square root of 28 is a little bit more than 5. So 1, 2, 3, 4, 5. It's an estimate, y'all. 1, 2, 3, 4, 5. Okay, so from here, what you're going to do is you're going to draw this box. And it's going to go like this, using the points that you have that you put with your vertices, and they're not called co-vertices. And what this is doing, and I actually may add this too so that it can help you understand and realize how easy they are to do. Okay? I'm not getting bogged down by any numbers. I just looked at my equation. I went left and right 6. Up and down the square root of 28. And now I'm going to try this. Y'all bear with me. Let's go with drawing the asymptotes. So the key is the asymptotes are the diagonals of this box. So I'm using my ruler, going through the center, going through that diagonal, and that diagonal. Those are my asymptotes. Okay, now back to my pen because I'm going to draw it. Okay, we already put where the vertices were, and I should have told you, usually when I graph these things, I actually put an X here to help me remember which one is going to have my branches. So the one under the negative term, okay, this is the negative term because there's a minus in front of it. We put X's. We know that the parabola, the hyperbola is not going to be graphed there. So then I just go from my vertex, that is a point on my hyperbola, and I'm going to graph towards my asymptotes. Okay? If you, that's hilarious. If you have to write the equations of the asymptotes, just to help you out, okay? It is the tops of this thing, okay? Y equals plus or minus something x, okay? You just need the slope. Well, how can you find that slope? It's basically up. How far did I go up? I went the square root of 28, and I went over 6. So the slope is, stop. Come on. Thank you. The slope is the square root of 28, which is 2 square roots of 7 over 6, which becomes the square root of 7 over 3. Now, it was not asked for on this problem, but I'm just telling you, you can remember the equations, but I didn't even tell you what was A or B. I just said, here's the center, I went up and over to the corner of my box, which happens to be, there's my up number, the square root of that, of course, is my up number. The square root of that is my over number. So that becomes the square root of 7 over 3. Okay, again, just trying to give more examples because I know it's been challenging for people in the past. So let's go to example number 2. All right, so the asymptotes, excuse me, the asymptotes for horizontal hyperbola are those two numbers, and the vertices are 9 and negative 9. So I have a vertex at 9, 0, and I have another vertex at negative 9, 0. Vertex. So you should be yelling at me that you know what the center is. The center is 0, 0. And that again is going to be a horizontal one, okay? Which means it's going to be x squared over something minus y squared over something. Okay, I don't have plus or minus because I have 0 for both of them. How far did I go in the x direction? That's my center. That's what I'm going to do here. That's 9. And 9 squared is 81. So that's enough to tell me where the center is and tell me that a is equal to 9. Now, is that the top number or the bottom number here? Okay, it's my x, and the slope is y, change in y, over change in x. So in this case, it's 9. So what has to be the change in the y is 7. That means that b is equal to 7, so what's going to go underneath my x squared is 49. And that is it. They already told you the asymptotes. If you needed to find foci, well, let's go do another one, and we'll figure out. We have 2 more, and then we'll be done. So let's go here. Okay, so graph this equation, identify the vertices, foci, and asymptotes. So, my center, I hope you didn't say 4, negative 3, because h is always with x, and h comes first. So it's negative 3, 4. That's my center. So I'm going to go 1, 2, 3, 1, 2, 3, 4. And I hope you're all, since this was first, I know that my hyperbola is going to open up and down, because my y squared term is positive, my x squared term is negative. So this is the one I'm going to put the x's on. So I have my center. I'm going to go left and right 3. 1, 2, 3. 1, 2, 3. How far am I going to go up and down? 5. 1, 2, 3, 4, 5. I'm putting an x. 1, 2, 3, 4, 5. Putting another x, because I know, LOL, I did that wrong. So you've probably been yelling at me for the last 5 minutes. I'm supposed to be going up and down 3. 1, 2, 3. How did I know that? Because the 9 is under the y. 1, 2, 3. And then I'm going left and right 5. 1, 2, 3, 4, 5. That's where my x's go. 1, 2, 3, 4, 5. That's where my x's go. Okay? But that is enough to allow me to draw my box. So we're going to go draw our box. We're going to go boom, boom, through these points that we have drawn. And then after I do that, I'm going to go, it changed, and put in my asymptotes. So there's one, and here's the other. Pretty good. And now we're going to go back and graph it. Okay, so I know that that's my vertex. I'm going to have that point, and then I'm going to approach the asymptotes. Okay, so there's my graph. Identify the vertices, the foci, and the asymptotes. So my vertices are right here, y'all. Vertices. So if I have to name them, I don't have to remember any formulas. I just know where I graphed them. So this point is 1, 2, 3. So this is negative 3, comma 1. And the other one is negative 3, 4, 5, 6, 7. Negative 3, comma 7. Foci. How am I going to find this foci? Now, I will tell you this, y'all. We just noticed the foci are always inside the curve. So when I get them, I know that the -3 is going to stay the same. But this right here, A is always positive. So I know that A is, well, I don't need to know A. I just need to know the equation. C squared equals A squared plus B squared. This is always different from that right there. C squared is what I'm looking for. A squared is, stop it. Golly. I'm being attacked by a virus. C squared equals 9. Oh, please. C squared equals 9 plus 25. So C squared equals 34. So, no. Yeah, how many people yell while they're recording videos? Let me try to clean it up. I'll be back. Okay, I'm going to try to finish this problem. So you saw me get to C squared equals 34, C equals plus or minus the square root of 34. My y coordinate's changing, my x coordinate is not. So I say that the foci are -3, 4, because that was my center point, plus or minus the square root of 34. So we're done with that. We have to do the asymptotes. So the last thing about our asymptotes, you're taking the tops of the equation right here, y'all, without the squares. So y, y minus 4 equals plus or minus some slope, and then x plus 3. Go to that center point. That is the point -3, 4. How far did you go up? 3. How far did I go over? 5. 3 over 5. So everything you need to answer these questions, you're getting from graphing it and not getting bogged down by the formulas. Okay, this last one is a word problem. I do it because I know you encounter something like it next year. Actually, look like that. I got 2 of them to help you. You're going to encounter one similar to it next year and in your homework this year. So let's go. 2 receiving stations that are 150 miles apart receive a signal from a downed airplane. They determine that the airplane is 80 miles farther from station A than station B. Determine the equation of the hyperbola centered at the origin on which the plane is located. So what we have going on here is we have, if you think about your coordinate plane, centered at the origin, so this is the center. The 2 receiving stations are 150 miles apart. So if I have a receiving station A and a receiving station B, they are the same distance apart, then this distance, a whole distance is 150, so that distance is 75 on both sides of my origin. Okay, and then I have some kind of plane out there, and I'm going to add another. So my plane is out here somewhere, and he is flying on a path that says, okay, the key, they determine the airplane is 80 miles further from station A than station B. So if you think about, those are your foci, so you're going to have some hyperbola doing this. Okay, the plane is up here, and the distance from here to here, okay, that is that they're telling you that the difference between those 2 distances is 80 miles. And if that's 80 miles, that's that constant. So that tells me what A is, 2A, excuse me. So that means that A is 40, which means at this point right here and here, that is 40 units away. And that, of course, is A, as I just said. This is your foci, so that's C. All right, my parabola is left and right, so I got x squared over something minus y squared over something equals 1. How far did I go left and right? 40, and 40 squared is 1600. How far did I go up and down? I don't have any idea, but I do have, I'm going to change it so it's a little bit easier for you to see, so I'm not on a graph. I have my equation, c squared equals a squared plus b squared, different, because that's minus. It's always the opposite. C squared is 75 squared, which is 5625. A squared is 1600. Well, at least it's green. You can tell the difference. Plus B squared. And so when you solve that equation, 5625 minus 1600, you're going to get 4025, which is the number I'm going to put right there. And now I have the equation of my hyperbola. Okay? So the last thing I want to do is complete a square, because this people tend to get tripped up when there's some extra negatives involved. So I'm going to go put this equation in standard form, and it is similar to what you would have to do on a lesson check. So I want to make sure you get to practice in your homework. Okay, so I'm keeping the one that's positive first. No sense in changing it around. The standard form of a hyperbola has it first. Okay, so 81, but remember I always have to have the coefficient of my square term has to be 1. So I'm factoring out that 81. And 81 goes into 810 10 times, plus a blank. And then minus, got to factor out the 16. X squared, 96 divided by 16 is 6. And then I got to move that 585 to the other side. So I'm going to have negative 585 plus a blank, and then minus a blank. I'm doing the same thing to both sides. This one is being added. It's inside parentheses, in which 81, everything's been multiplied by 81. This one is inside parentheses, in which everything was multiplied by negative 16. So what number am I going to put in here? Half of 10 is 5. 5 squared is 25. Half of 6 is 3. And 3 squared is 9. So when I go back to factor, I have 81. Y minus 5 squared. You're taking this without the exponent, that without the exponent, and it always takes the same sign. Minus 16 times x plus 3. Oh, guess what? When sorry if you're yelling at me, I didn't pay attention there. 96, you take out a negative 16, this becomes minus 6x. So this would be minus 3. It doesn't change any of these because I added a positive number. Okay? So it is going to be 81 times y minus 5 squared minus 16x minus 3 squared. And when I simplify this, I get 1296. To put it in standard form, I have to set it equal to 1. So I'm dividing everything by 1296. And you probably could figure out that 81 times 16 is 1296. But if you didn't, you will soon enough. So y minus 5 squared over 16 minus x minus 3 squared over 81 equals 1. And now I have it in standard form, and I know my center is at 3, 5, and I know how to graph it. So that you got to be careful with what I just did. Didn't take me until this step to realize what I had done, but that's what trips people up. Okay? And when you're doing it on different sides of the equation, like we are here, but we didn't on a parabola, then you do the same thing. When you're doing the different sides, you do the same thing on both sides of the equation. All right, that ends our lesson of hyperbolas. If you have any questions, please don't hesitate to email me or come see me. Thank you very much.